good afternoon, or good evening, or good morning, or whatever it is in the time zone that you're in. And welcome to the virtual awards, the award ceremony for the virtual version of this year's UAS challenge. Conscious a few people arriving, but I'll keep going anyway. Thank you all very much for joining today for this ceremony. Again, I'm conscious that I've got people from literally across the world joining, wherever you are. So welcome and thank you for taking the time to join in here. This has been a challenging year for us all, and sadly, I think continues to be so. You know, it's been absolutely fantastic that so many of you have managed to get to this stage and be able to complete this competition and award here. Certainly for our ability to be able to run the first year of a virtual competition. And again, we'll talk a little bit more in detail about what that's come. So we just have the next slide, please, Christina. So just so you know what we've got coming on this afternoon, once I've finished, we've got a short sort of Ask the Industry forum, and I'll introduce the panel shortly with some good questions there. As ever, I suspect that we're going to run out of time on that after we get right in the middle of it, but we'll see where we get to. After that, the IMechE's president, Peter Flynn, will give a short keynote address before we hand over to Lambert, who is our head judge, who'll give a view from where we are. Then we get to the bit that you're all here probably for, which is the allocation of awards. And we've got a number of awards to give. And then we'll have closing remarks from Robert from IMechE and Yelena, who's going to do a vote of thanks at the end. And I guess, as ever, I'll get to say my final comments at the end. So a lot to pack in over the next, short period of time. So what I'd ask, we're on Teams, so please, I think most of you are doing this anyway, if you could keep yourself on mute unless you've got a question. If you have a question, please could you put it in the IM or in the notes at the side, and we'll do our best to pick them up. We will, I suspect, probably have more questions than we have time to answer, so we'll do our best to answer those questions separately as we've done before. As you can see, this session is being recorded. That's really important for a conscious number of people who are unable to attend this, so we can put this up online afterwards, so you can see this and again pick up some of the other comments afterwards. So yeah, that's being recorded. Okay, so that's the plan for now. I'll just step on now to the next stage, which is the bit of an Ask the Industry forum. So we'll see how this goes in terms of an online. We've done it before online, and it worked last time we did this, didn't we? So I'll just introduce, and again, we've got Furkan from GKN, Michael Ovard from Leonardo, and Phil Briggs from Kinetic. Maybe if you just spend just a minute or so introducing yourselves. I can see some cameras are on. Just saying hello. Furkan, did you want to start?
Yes, hi. Yeah, I'm Furkan from GKN Aerospace. I'm the technology manager for future flight at GKN. So I look after our technology projects in exciting areas like unmanned aerial systems, urban air mobility, and I was a previous competitor at the UAS challenge and a judge previously as well. So I'm very excited to be here.
Thanks, Furkan. Yeah, always we'd like to recycle our students and our competitors. So we've got a few of them growing and sadly getting older, but there we go. That's a different conversation. Hi, Michael. Did you want to introduce yourself?
Yes, hello, everyone. My name's Mike Ovard. So I'm chief engineer here at Leonardo Helicopters in the UK. I'm actually head of the design organisation as well. Sadly, it's a long time since I graduated. And I think I can remember what it's like to be an undergraduate, but only just. Here at Leonardo, we design helicopters, and we have a very big interest in the future of UAVs in our sector of the market.
Thanks, Mike. Appreciate that. Thank you. And Phil?
Hi there. Yeah, I'm Phil Briggs. I work at Kinetic, and I've been working with unmanned air systems for nearly 15 years now, and I was joined the competition when it started, and have I think I've learned more from you guys competing in these competitions than I ever thought possible. So yeah, I'm very pleased to be here and hope to be here for some time to come.
Great, thanks, Phil. So as we're virtually doing this, I'll pose the question, and then I'll if it's okay, I'll leap around each of you for a view, and then we'll sort of have a go. I feel we're going to be moved on with question timing, because I think we could probably spend the whole afternoon discussing some of these issues, but we'll see what we get to. Can I just have the first question, really? So you see there, the first question again, we're really given sort of the audience that's listening in, you know, as a predominantly, not exclusively undergraduate, really the question here is around, so, you know, we're looking at you guys again taking in graduate engineers. What sort of skills, I'm looking both technical and leadership, really, please. Do you think universities could better prepare for graduates for the future? I'm very interested to know what you think when you see the graduates coming in. What do you think they both strengths and weaknesses, and where maybe could the universities help people moving forward? I'll just because you're top of my screen, Mike, I'm going to go to you first, if that's all right.
Yes, fine. So when we're recruiting, our starting point is good academic achievement in a degree course that we recognise and we've accredited. The thing that stands out for us, though, is where a candidate has done a project which we would view as relevant for our sector. So that will really stand out on a CV. For me, I would also like to see academia using industry standard tools and tool sets more than they do at the moment. By which I mean the aerospace standard tools like Fluent and finite element techniques like Abacus and Nastran. We also look for good interview performance, and in both the interview and the CV, we are looking for evidence of a personality and team working experience that's going to fit into our team structure. So really no surprises there, but be interesting what the other panel members say.
Thanks, Mike. Yeah, I think you brought up some really key points. So I won't come back to you straight away on that one. I'll just jump now to Phil.
Yeah, sure.
Your perspective.
Yeah, it's strikingly similar. I think, you know, academic ability is the first starting point, but the next thing we're kind of looking for is sort of the self-application of that ability to something that's relevant and important, and sort of the development of the knowledge and gained in the university setting, and making it relevant to the industrial thing. So, you know, what have they undergone some industrial placements? Have they applied what they've tried to learn through that time? And then I think after that, then we're looking for really solid evidence of teamwork. Everything these days is done collaboratively, and it's so important to be able to show that you can work in teams and teams of teams and share and communicate strongly in those sorts of environments. So that's another area where we really like to do it. And I think that's another reason why we choose to support this competition, because, you know, you get to get a lot of that type of experience through participation in this event.
Yeah, thank you, Phil. So lastly, coming to Furkan, who's probably a bit closer to remembering from the undergraduate and graduate experience than maybe some of us. So I appreciate your view.
Yeah, so, you know, when we're recruiting graduates, we don't really look for expertise in any particular technical area. We're looking for generalists who are willing to learn, willing to improve, and we expect most graduates with good degrees to be as technically sound as you'd expect a graduate to be. So we look for differentiators, especially around practical experience. I think universities do a great job of teaching quite a bit of theory, but students often don't get enough practical experience until they start their professional careers. And they have internships, they have placements, and they do certainly help. But this is where opportunities like having worked on a project like the UAS challenge, where graduates carry out a complete design and build from conceptual work to flight testing, really helps set them apart. Now, this is a personal opinion, not a GCAN recruitment policy, but anyone who's designed, built, and flown something start to finish, even if it's a small UAV, will have made several mistakes along the way that will have made them a better engineer.
Yeah, thank. That's a really good point. Yeah. Yeah, so I'm again recognising all of those points. I should say so. I'm when I'm not doing this, I'm the chief engineer of the RAF. So I have a similar sort of view of our graduates, and I think certainly the conversations here around team working, leadership, not putting down almost assuming technical skills is probably a better way of saying, isn't it? So I think that's a really important point there. So I suppose going back for kind of on that point, what from your experience then, what do you think if you could have got your university time again? What would you think where could the university have focused better on?
Yeah, I think it's providing opportunities to get a bit more of that hands-on experience. Industry is moving more and more towards digital tools, more towards design by simulation, but fundamental physical experience, understanding how basic machine shops work, understanding how prototypes are made, understanding what goes into making a wind tunnel model, getting access to a wind tunnel, being able to run even very simple experiments. Those aren't opportunities every university can offer their students, and this is where we start becoming quite selective in the universities we want to recruit from as well, because we want to see students who have some tangible experience, who have something to show for a lot of the theory they've learned, who can apply it, and generally with research-based projects, it's really difficult. It's really difficult to show something at the end of it that's more than just a report.
Yeah, good point. Good point. Yeah. So I guess, yeah, I mean, those are challenges. I guess it depends on which university you went to, but also their ability and what they can learn. But I think these are important things that we start. I think this is important that we push back on some of these things for universities. And again, I would say the competitions are key to that, but I think these are helpful. So Phil, any sort of final thoughts on this one?
Yeah. I mean, I think the first thing we need is possibly more routes into the career of engineering. I think things like apprenticeships are really interesting way of working in industry whilst gaining the knowledge and having that opportunity to apply the learning to a real world environment at the same time is fantastic. And I think those apprenticeships can include participation in degrees and undergraduate and postgraduate studies as well. So I think that's a really important thing. I think the other area really is about bringing to life some of the probably quite bland physics and maths at the very early stages when people are trying to make subject choices for exams and things like that, and showing them how actually exciting and interesting careers in engineering can be. I think about some of the things I've had the opportunity to do in my career. That was such a long way away from some of the physics and maths I learned at school, but actually had I known some of those things, it would have been a much easier choice.
Yeah, thanks, Phil. I'll go back to you, Mark. I mean, obviously, Leonardo, you run a very big and successful apprenticeship schemes and other entries. Unconscious that you guys do that as well. So, I mean, would you sort of understand where Phil's coming from on that?
Yeah. I mean, the only addition I would make is I'd like to see more universities have a year in industry as part of their degree construct, because when I was an undergraduate, I was actually sponsored on a thin sandwich degree. So picking up on Furkan's point, the mixture of time in industry and then time in academia interspersed with each other does give you a view of what is truly relevant to industry to allow you to, when you start your career, to hit the ground running. So so that can be very useful. But of course, it's also beholden on industry to offer the placements, during the undergraduate process.
Yeah, thanks, Mark. I think you're right there. Yeah, absolutely. So I guess it's getting, yes, the question also goes back to industry, isn't it, to offer those places as well and offer those opportunities. Yeah.
Yes.
And for the vast majority of engineers, I know not 100%, you know, as you said, it's your application of your skills, not just your skills, and that understanding the working environment is so absolutely critical. So really good. Thank you. We'll just step on to the next question, please, which I think is kind of almost brings it just carries on this discussion really a little bit here. So I suppose this is you know, what can governments, and again I'm probably looking, because I'm looking at industry now to some degree, what do you think, you know, you could be doing, or clearly other companies, not clearly your company, because clearly your company's perfect, but other companies could be doing to help that out? Maybe Furkan, can you sort of, what's your view from GKN's perspective on that one?
Yeah, I think a big part of it really is the perception of what the role is, of what an engineer is. You ask most kids what they want to do when they grow up, and they'll tell you they want to be a doctor, a pilot, an astronaut, you know, something like that, something they'll have seen in a TV show, in a movie, and you don't really see engineers, portrayed in any of that kind of media. And you'd ask a kid, what do you think an engineer does day to day? I don't think you'd get a very very clear answer, or a very good answer. So I think the first step is really to spread awareness, promote engineering careers to kids at a very young age by showing them how cool some of the jobs actually are. And I think the second factor is a stereotype that having getting an engineering degree and having an engineering education is extremely difficult. They're not the easiest of degrees, but you don't need to be a child prodigy to be an engineer. The point of educating engineers is to teach them the core maths and science skills that they can then apply. But the stereotypes make students think that they already have to be experts in maths and science before they even pursue further education in engineering.
Yeah, thank you. Good points there, Phil.
Yeah, sure. I think I'll pick up on a point maybe Furkan made very well earlier on, is that, you know, the core skills that you develop as an engineer at university around those academic things, that they're actually a beginning point, and the choices once you go beyond are quite broad. So I think, you know, it's about setting out examples of role models and things that people can aspire to more broadly, and show how interesting and fulfilling those careers can be, and show that actually almost from any baseline engineering start point, you can reach interesting places in an engineering career just by through your development as you go. You know, every day is a day of learning, really, when you're in an engineering role, and that's something to be really.
Yeah, I agree, Phil. 30 years in, every day is a school day. I truly say that. I learn something new every day. Absolutely right. That's great. So again, from Mike, from your perspective, what's your views on the question?
So from my perspective, the first thing I thought of when I saw this question was that we need a more equal gender balance in engineering, because the current situation we've got it's akin to discarding 50% of the candidates before they even reach us. I don't think that's industry's fault, by the way. I think that's a societal issue, because we need the school system and society in general to be encouraging more women to take up careers that are science and mathematics based. And that in turn would feed more candidates into engineering. I think from an industry point of view, we need to be making sure that we have career profiles that are more sympathetic to parenthood and motherhood, so that career breaks without penalty to career are built into the way we operate. So I think gender balance is one part of this. I think the other part of it is to think governments should be thinking about whether certain roles within, whether that be industry or government, ought to be mandated to be chartered engineers, particularly roles that have an impact on safety. And I think if those roles were mandated to be chartered, I think that would raise the professionalism and the perception of the engineering career.
Yeah, I totally agree with Mike on that one. I think that has often been a challenge, and I'm conscious that we might be talking to some degree about the UK. I know in other countries it's sometimes a little different, but absolutely that lack of requirement to have a professional, recognition is a real challenge in terms of it. So in the Royal Air Force, we have now mandated, as you're well aware, and I think you're the same, and I feel as much the same as well, is that you have to be a chartered engineer or incorporated engineer in order to sign off airworthiness documentation. So we've started on that journey because our regulator won't let us otherwise. So it's the regulation is coming, but in other areas which are safety critical. Let's face it, everything we do in engineering has a safety criticality about it, be it functional rather than airworthiness. Absolutely critical that we do hold that. So I'm absolutely with you on that one. That really interesting. Yeah, and again, these are things I think themes that are really helpful to take forward. Again, in the both engaging with industry, but also engaging government, because we've got to. Across the world, we need more engineers, irrespective of conscious, with not just speaking the UK here. Across the world, we need more people coming to engineering. Of the right, a complete mix. We need to access everybody in that society who's got the skills and desire and drive to get, have a fantastic career. So that's great. So thank you. I better step on. We haven't got a huge amount of time, so we're moving more sort of technology now. So again, I'm conscious this is now probably like a whole day's conversation, but we've got a few minutes. So I'm going to kind of ask you to sort of maybe just give your top one really, and what you think your version of the photon torpedo Klingon cloaking device is going to be. And again, I'm going to I'm going to go, because you're in the middle of Phil. I'm going to go for this time for you, Phil, because you're in the middle for this time for this one for my picture. So
yeah, sure. I think I guess the point of a UAS really is to deliver some information or a bit of or a package or something. It has a role to perform, and it sits inside a much broader system of systems. So I think the really big thing that's going to change how we use and build UAS is going to be some of the big data and processing that goes around them. How do we integrate them into airspace? If we're going to have massive package delivery systems that and potentially thousands of these things flying around, how are we going to deconflict them? How are they going to stop from bumping into each other and other manned aviation? So there's a massive challenge there. We've got a very prolific delivery system going on, and then how much and where do we do all this processing? Do we do it on the UAV, or do we do it somewhere else? And if we do it somewhere else, how do we get the information from the UAV so there's some really interesting challenges there about where do we do things and why do we do things the way that can turn upside down our thinking about how we employ the UAS in future. So I think that would be my one.
Yeah, thank you. Yeah, I'm conscious of Kinetic's involvement in a lot of this stuff, so absolutely right. Yeah, in terms of supporting this technology development, so absolutely right. Yeah, thank you. Furkan, what's your thoughts on this one?
Yeah, I think detect and avoid and autonomous flight controls will really allow unmanned systems to be used in a very different way. When you can have pilotless operations or one operator looking after multiple UAVs, you open up the opportunity to really scale UAS adoption. There simply aren't enough pilots and air traffic controllers to scale otherwise. I think the other key bit is electrification, improvements in batteries, electric motors, energy and power densities, and hydrogen fuel cell technologies will really enable longer missions that can add more value. This also ensures future platforms are more environmentally sustainable, they have less emissions, and they're socially more acceptable as well by being quieter. Noise will really be a big issue as we try to scale some of these operations. And in the urban air mobility space, this is clearly happening with electric vertical takeoff and landing vehicles.
Thanks, like, really good. So obviously, Mike, I've left you with all the sandwiches eaten.
Yes.
So I see what you.
I was reflecting on the excellence of preceding two answers, but I would add perhaps the greatest barrier at the moment is the challenge of certification and being able to demonstrate to the regulator that you've got an equivalent level of safety with an unmanned vehicle when you haven't got a pilot on board as both your reversionary mode and also your health sensor for the vehicle. So certification is going to be a massive challenge.
Yeah, I absolutely, totally recognise that. I'm heavily involved in the certification of a number of UASs or RPASs, or I do recognise that those challenges. I mean, I think that you see the technology coming, but I think we've discussed before. It's a regulatory environment to allow that technology to be absolutely delivered. I think we know we can do detect and avoid. We know we can do that, but how does the regulation work? And I think that's critical. That we talk about technology, but without that, we are struggling, aren't we? So
in some ways, it's probably more achievable in a military environment when you're operating training on a range or you're operating in time of war. But in the civil market space, where you're in congested airspace with manned and unmanned vehicles interacting in controlled airspace, then that's when it becomes really difficult.
Yeah, I agree. And I think that the issue there is, otherwise it's going to become niche technologies, aren't they? If we don't get that open into the wider airspace. You're right. Having a danger area or a controlled airspace is fine, but again, even that we're seeing now in congested airspaces in operations, it's rarely actually do you own the airspace. Others do as well and need to operate within it. So and in a safe way. So absolutely right. So I think we're going to have to. That was really interesting. So thank you, Furkan. Thank you, Phil. Thank you, Mike, yet again for your time on this. I suspect, given the chance, we would have happily chatted for another couple of hours on this. But so your insights were always really useful. So thank you very much for taking the time to do this. Sadly, we missed a question there, which is all about the challenge, but we'll come back to that one, which is keep being a sponsor. That's what it basically says. So it's important. So but thank you very much for your time, and hopefully we'll actually get to see each other physically again soon. That'd be rather good. So so we're now going to move on to the actual ceremony, the award ceremony. Now, first of all, we've got a keynote address from Peter Flynn, who's the president of the IMechE. So Peter, I'll hand over to you.
Yes, well, thanks very much, and good afternoon and evening, everybody. And that was a very interesting conversation, and it's one that I've picked up a lot of interesting points from. I hope everyone is keeping well and surviving in these somewhat strange and difficult times. And it's very good indeed to see something in excess of 100 people on this call. And thank you for inviting me today. And I am very pleased indeed to be able to make a contribution to this meeting. I'm sorry, of course, that we can't meet in person, but I think things are opening up. And in fact, on Monday of this week, in one of the UK design challenges, we did manage to get together physically a group of 20 or 30 undergraduates for their particular competition. So things are opening up. So in terms of our institution and the role of our institution as a professional society, one of its key roles is to support engineers in their development and thereby to promote mechanical engineering and, as we say, through the endeavours of engineers, to improve the world through engineering. And I think this type of challenge is an excellent example of how we can support engineers in a very practical and hopefully interesting and even exciting way. I'm particularly pleased about being involved in this type of activity, which is all about design, manufacture or virtual manufacture, and subsequent testing of prototypes, if I can describe it that way. Because that's been a big part of my own engineering life, mostly in physical form. I did actually, after I left university, which was more than several decades ago, although I can still remember it, I was involved in military aircraft design and development. And I think that a competition of this type is an area where the engineering theory that you learn at university meets practical reality. And what is engineering if it isn't producing some useful invention, which then goes on to be made in quantity? And my own field activity and the presidential address I gave a couple of weeks ago was very much around the subject of how to turn invention and innovation into business, where that business then provides society with useful goods and also provides employment and investment opportunities and so on. Now obviously, your ideas are probably still at a relatively early stage of development in the development process, but who knows? They might form the basis for for future business and future opportunities. And in many ways, I think that there couldn't be a better time for people to go into engineering, and the conversation about the shortage of engineers was very interesting. The world faces some major issues which only engineers can solve, and you can describe them in many ways: decarbonisation and electrification, energy generation, better use and reuse of scarce materials, to name a few. But I sometimes also think we overlook the extent to which engineering pervades our everyday life. And when a similar question was put to me recently, I happened to have a Coke tin in front of me, and it struck me then that in that very simple and modest object, there is quite a lesson in metal forming, joining, painting and printing, and a number of other technologies. And I think the world perhaps underappreciates how much engineering surrounds them. But having said that, I do hope that you've enjoyed taking part in this challenge, and particularly that you've learned something from it. So I'm looking forward to hearing more about what you've done and how you've responded to the challenge. And so thank you once again. And I think I'm now going to hand over to Lambert, who's going to talk about the judging. Thank you very much indeed.
Well, hello everyone, and welcome to the award ceremony. I mean, the challenge has certainly been quite a challenge this year for us all, and particularly for you, the teams. And it's been a bit of a challenge for the judges as well, I'd have to say. If we could just move on to the next slide, Kirsty, please. Well, what I've done here is I've cut and pasted the images of your aircraft from your reports. And as you can see from this, I mean, there's a huge variety, some fascinating ideas, very diverse, no two alike. And so it is pretty disappointing, actually, that we won't get to see these fly this year, or you to make it to the live event. But it's given us a lot of interest in judging them. One thing you have had the experience of by going to this virtual competition is another of the important tools for aircraft designers, and that's the flight simulator. And as Furkan said in the industry forum, simulation is becoming increasingly more important as part of the process in which we design aircraft, because it's a way you can explore a lot of ideas safely and really quite quickly before you get on, as we used to say in the past, cutting metal, but of course not much of it is metal these days. Now, as part of this challenge this year, you ended up really having to produce quite a number of reports to deliver to us. We've had the concept paper you started off with, then off onto the design report. You've undertaken 2 design reviews, which are very important stages as part of the design and development process of an aircraft. And then we asked you to do a manufacturing support and test report, as you weren't able to actually show us the finished product. And then we introduced the X-plane simulator. Now, you put some tremendous effort into this, and we much appreciate what we've seen. But just one little observation, if I may, rather than sort of doing comments on all of them, is that please do be careful about reading the instructions. It's really important that if you're asked to present something in a particular way, you do it. even if you don't necessarily agree that that's the best way of doing it, because it's always better to keep the customer happy. And it's something that you'll learn as you move into industry. And so following the instructions is a really important way to success. Now, I'm just going to briefly go through and remind you of what the judging criteria were for each of the awards, and a little bit about the scoring. So the awards that are available for the virtual teams are the ones written there. And so the most promise is a fairly subjective award from the judges, is the one which we saw as being nearly the most successful flying vehicle, but for various reasons didn't quite make it. The Environment Award is all about environmentally sustainable design, and so we just looked at your reports to try and judge that. Again, a fairly subjective view. Safety, we looked at the two reports, the design report and the manufacturing support and test report, and how you wrote about safety. Again, we would normally like to see that seen in practice at the live demonstration, but we've had to rely on what you've written in your reports this time. Innovation, again, is a somewhat subjective field, but again, it's the judges, and there are a dozen of us highly qualified engineers who judge this competition. We just voted on what we'd seen from your various inputs. And then we come to the almost the more mechanical ones, which are the first place runner-up, third place, and highest place new entrants, which are an amalgam of all the scores you've made through your reports and through flying the X-plane. And so first runner-up and third place are fairly obvious. The highest place new entrant is the team that scored highest, who is a new university to the competition. If we just go on to the next one, please, Kirsty. And so how the scores work out, and it's done in a similar way to the live competition, is there are 260 points available for your design and development reports. So the four deliverables there, each score points that add up to 260. And then there's 340 points available for your X-plane simulation, so making a total of 600 points all together. And so if we move on to the next one, please. And so just a little bit of explaining about the X-plane scoring of how the 340 points are made up. There are three flights that were done on your X-plane. One doing the circuit, doing the payload delivery. One just taking the aircraft up, putting power off, putting it into a glide to do the glide ratio measurement. And then finally the speed challenge, which was just going around the course and looking at the average speed around the circuit. And so the score was on takeoff up to 40 points, which was basically 30 points if you did it within the 30-meter box that's as part of the requirements in the rules. But also there was an additional 10 points for the pilot's view of how well the aircraft handled. The payload carriage and delivery was made up of 25 points per kilogram of payload that you were carrying, and then you got 25 points if you managed to successfully release the payload. The efficiency score of 40 points was a calculation of the energy that you use going round the payload delivery circuit. Climb and glide, as I said, was taking the aircraft up to height, putting it into a glide, and then calculating the glide ratio that you achieved. Navigation was, as you went around the course, you scored 3.5 points for the pilot being able to get around, or in fact through the gates. The course is laid out a bit like the Red Bull sort of aircraft challenge thing of flying through gates. And then there was an additional 8.5 points that the pilot awarded for how well the aircraft handled doing that. Landing the opposite to takeoff, so the scores in a similar way. And finally, there was 40 points for your average speed around the circuit. And so that was how the 340 points were made up. So that's a very quick run through the judging. It was really interesting doing it. We do applaud the efforts you put in, and there were some really good reports this year that were delivered, and some quite interesting insights, and as I say, some very interesting designs. So thank you to both you, the teams, for your efforts there, and also thank you to my team of judges who have had to put in quite a lot of effort in going through all this. But I'll now pass you back to Paul for the going through the announcements of the winners.
Some claps there already, silent claps. Thank you, Lambert. Yes, that was a really useful update of where we've got to. Yes, and just to say, first time we've done the virtual challenge, so a really big thanks to Lambert and Christina, who here shortly, who've made this aspect work this year, from a zero start to be able to run what I think is an excellent competition and challenge, and able to give awards. It has been just absolutely fantastic. So now we move on to who's won those awards. And we'll step through them, and I'll introduce each of the awards and who's giving them, and I'll then that individual will actually announce that person or the team who's won, I should say. Clearly, at this point now, I expect you're all holding your breaths out there, which please don't hold it for too long, because it might take some time, so you probably need to breathe between them. But I would say that irrespective of how this goes, you are all winners in your own rights. And as we said, some outstanding entries. As ever, some really difficult decisions had to be made about who's going to win, and invariably somebody has to win. But please, please take it to have got this far, to have done the work you've done, to work together to get this far again during this challenging time, particularly, has been absolutely fantastic. So please, before we get on to this and who's actually won the awards, we should clap each other now. I think is what we should do. We should clap each other for the excellent work you've done. So now there we go, excellent, thank you very much. We'll now move on to the actual awards themselves. I'm not technically astute to how to do that. So the first one, as we said, was the most promising award, and Gillian Cameron, who's come on this year as our new deputy head judge. So Gillian, I'll hand over to you to let us know who won this award.
Thanks, Paul. Yeah, it's been my first year taking part in the competition, and it's been really interesting. As everyone's been saying, you've all worked really, really hard. The award for most promise goes to a team where the UAS just couldn't quite take off and explain. It was a hybrid VTOL design, and like all the hybrid VTOLs, actually, it proved to be quite tricky to implement and explain. The explain pilots, however, did believe that if a successful takeoff could be accomplished, then it would, had great potential to fly really well. So well done to the team. The award for the most promise goes to Drone Team 20 from the University of Twente. So congratulations.
There you go. Good claps. Excellent. Well done. Well done. Well done, Team 20. Well done. Fantastic. Suitably distanced picture there as well. Excellent. Excellent. Well done. Maybe next year we'll see it fly, and it'll, and you'll show that actually it didn't just have promise. It was going to be a magnificent UAS and aircraft design. So great. Thank you very much. Next award, please. So now we move to the environmental award. So Andrew Bradley, who is the chair of the Airspace Division, and is also another judge, will do that award. Hi, Andrew.
Hi, Paul. Hi. Thanks, and good afternoon and morning and evening, everyone. The environmental award. Well, this award this year, we've had great fun as Gillian said, reading all the reports, trying to work out who's got the best environmental credits. And this year, all the teams have had to use electric propulsion, and the efficiency will be measured, as you saw from the work. But in particular, we were looking also at teams to reduce their environmental impact by choice of materials, reducing waste, noise, etc. And the team we've selected is the University of Moratoria, Team 25, for their aircraft Mora avions. We particularly like this team for the ways they reduce pollution by using old Coca-Cola bottles, plastic bottles, as a second life in construction, and also creating sheet fibre using banana leaves as a fuselage covering. So well done to Mora avions.
Thank you. Well, that's some very interesting designs. I'd like to have seen some of those. There we go. See how those Coke bottles work. Excellent. Well done, guys. Excellent. That's fantastic. So again, some environment is growing in importance as we go through, or continues to grow. Really important. So that's a really important award. Thank you very much. So next I've got I can see hi Andrew Monday from Babcock, who's going to be doing the safety award.
Thank you very much. And safety sometimes can feel like it's the less exciting part. But if we think that UAVs have been around since 9000 BC in the form of kites, getting things in the air has been done for years, and it's often been there to help with safety. And when we look at things nowadays, mastery of flight, it's really a really key technology. But what makes the difference isn't just getting into the air, but delivering the mission and doing it safely. That's what makes it a really complex problem. So the safety work that you have all done as part of your project, it's been great to see how you've applied yourselves to that. And it's a really key thing to include as you move forward in your careers. And for us at Babcock, it's extremely important to us and our teams. We're always playing with innovative new toys, but we need to enable people to do it in a safer way. So we do that whether we're using UAVs to support last mile resupply or providing foresight and preventing wildfires. So it's a key theme throughout this challenge, and this is my first year judging the challenge, and it's been really interesting and great to see the range of designs that you've done and the way, as I said, that you've looked at bringing safety into that. We have been through and assessed the evidence that the teams have provided in your written reports. Before announcing the winner, just like to recognise as highly commended Team 9, Islamic University of Technology, but there can only be one winner. And from their combined reports, which gave an excellent explanation of their general approach, and also included a really good hazard table with the clear consequences of concern, the preventative and the corrective measures, I'm delighted to announce that the winner is Team 13, National University of Science and Technology, Team NUST Airworks. Well done.
Yeah, well done, Team NUST. Thank you very much, Andrew. Safety absolutely critical to everything we do in the aerospace sector. So some really good advice there, and things that again hopefully people can take forwards in the future. So thank you very much indeed. Next award. So now on to the design award, and we have back Furkan back again. Hi Furkan, good to see you again to make this award.
Yeah, thanks, Paul. So the design award goes to the team with the highest scores from the design report and their 2 design reviews. It really considers both how the proposed solution meets the system requirements, as well as the process in getting to that refined solution. The winning team had an interesting hybrid design with 3 tilting rotors. The team undertook a really good piece of work on requirements capture and followed this up with a very detailed description of their design. Their design description was supported by solid aerodynamic instability calculations, and overall they delivered a well laid out and comprehensive report and supported it with 2 very good design reviews. and being able to back up your technical data, being able to back up your design reports when challenged in design reviews is really an important skill for any aircraft designer. So congratulations to Team 9 from the Islamic University of Technology.
Thank you, Furkan. And again, well done, Team Ants. Who look like they're standing on a roof, which again does concern me slightly, but I'm sure that was absolutely low and you're okay. But there we go, fantastic. Well done, indeed. A good sizable team there winning that one, excellent. So thank you, Furkan, for that one. So we'll move on. So we're next Winter Innovation Award. Hi, Phil, for Kinetic.
Hello. So the Innovation Award is an award typically when we've run the competition previously, we do via walking around the pits and talking to all of the teams and understanding some of the work they've done. We also ask you guys to talk about the innovation in your designs through your design reports. Generally, the way we measure this is by testing whether that design has made it through into the end vehicle. So judging remotely this time was a bit of a challenge, but I think the one thing we can say that there was innovation in everybody's design. If you look at the diversity of the solutions that you guys came up with in this slide that Lambert put up at the start, with all of those different designs that you've really come up with some interesting and great ideas this year. But the way we also judged it this year was to take your designs and put them into the X-plane simulation, and in there we got some quite interesting feedback for the winner of this particular award, and it was an interesting flying wing design that used interesting characteristics. So the winner of this design is Swansea team and Team Blue Swan, and the thing that we awarded the Innovation Award to was the use of the Prantl D wing design from NASA, where they adapted into their own design and used Proverse cooperative yaw to enable the stability of the aircraft, which was a very innovative design and actually flew extremely well in the X-plane. So well done.
Thank you, great. And that looks like an absolutely interesting design, and well done to Swansea for that engine. Again, hopefully we'll see that next year fly, and that'll be absolutely fantastic. So next award now, we move into the highest place new entrant, and Leonardo are going to present this award. So Mike, over to you.
Thanks very much. So clearly there's a very high standard in this year's competition. So to place highly, never having entered the competition before is something that is worth celebrating. This award's given to the university with the highest overall score from reports on the X-plane that haven't previously competed in the challenge. The winning team here is Team 11. It's the Democritus University of Thrace, DART. They designed a quadcopter inspired by the rescue challenges in the Greek mountains, and their design was driven by the need to keep the costs down. Now, those are two things that are really relevant to the rotorcraft industry, so that's to be applauded. The judges found the aircraft to be a little difficult to control in flight and land, but they did complete the course. So very well done to Team 11.
Thanks, Mike. Excellent. So yeah, well done to Team DART. Again, hopefully to see you next year, and again to see that design. And well done indeed. Well done indeed for your first time of entry. That is an excellent outcome. So now we move on to the sort of, as we run down the sort of top places. We're first going to do third place, and Christina Linden. And Christina, I should say, is the sort of the power behind this year's virtual competition. Quite literally flew the designs for you. So many thanks to you, Christina, for you do that, for your outstanding work. I mean, turning what was a really good idea into actually happening, which was a real challenge. So thank you very much for that. So, Christina.
Yep, so I'll start with just by giving some general comments. I've been asked just to give a little bit of an overview of what me and my test pilots actually thought of your aircraft. And honestly, you've all excelled in what you actually submitted to us. The standard of aircraft was absolutely phenomenal compared to the time period we actually gave you, and what you submitted was completely unexpected. When we were actually loading the aircraft, we did have to second guess ourselves as whether they were actually official X-plane models for some of them. So on that count, it was absolutely fantastic. And I know within the last meeting that we had, and I explained to you and submit some instructions, so I know how to fly them, and we don't have to go in and spend all our time, which we could be flying your aircraft, chasing up actually how to control it. And again, I was expecting a small document or a text document. No, you all went above and beyond, submitting actual instructions and saying how you wanted your aircraft flown. So it was great to see that you'd actually put in the effort to fly your aircraft as well, and actually establish the best way in which to fly it. In terms of the overall scores, there were small details that impacted your scores and changed and determined who the winners were. In terms of the payload, everyone successfully managed to do that payload element, which was fantastic to see. It was a difficult part to put in, but you all successfully could do that and integrated that. Again, it was small issues with each of the aircraft. And I think the overall comment from us was, please remember that drag is just as important as lift, especially when it comes to landing. And a lot of universities across the board, you lost points on landing just because of that one slight issue. So I think going forward, if you take that on board, some of these aircraft, you would have scored a lot higher in them areas. So in terms of feedback, I will provide you with it will be a very small feedback from the pilots on how they handled. And of course, I know you're all absolutely dying to have some videos of the test flights. All 3 flights have been filmed for you, so they will be available in the next couple of weeks. I will just condense them so that we can actually upload them to Mushroom so you can all have them. So you can actually see how your aircraft flew, and I know you'll all be really wanting to see that. So that's my feedback for the whole competition, but it was absolutely great. So thank you. And I know a lot of you sent in questions and asking me about X-Plane to Christina and her team, and some of them questions really tested me. So it was great for my knowledge as well. So I'll move on now to 3rd place, and I'd like to congratulate the University of Muratua and Mura Avions. Your aircraft performed exceptionally well within the X-plane, and overall you came 3rd within all the reports as well. So you're actually a very solid third place across. It's a single pusher propeller aircraft, and you actually scored one of the highest scores for the climb and glide. This aircraft actually, we had to make our runway bigger to allow it to actually glide to the ground. So thank you for making my job that a little bit harder, but it was absolutely fantastic to fly. So thank you very much.
Thank you, Christina, and that was really useful feedback. Thank you very much indeed. And I should say, for everybody out there, we are keen to learn from experiences. So feedback on how it went for you, how you found the process, as well as us how we found it from our end, and Christina found it from her and her team of test pilots flying the virtual thing. It's really important we get that feedback now. So now we run up the order to runner up, and Peter Flynn is back to present that award. Peter.
Okay, thank you very much. Yes, so obviously this award is given to the university which had the 2nd highest overall score from the reports and from the simulation. And you've already seen this solution actually. It's quite an interesting tailless blended wing body aircraft carrying its payload below the fuselage and controlled through elevators and rudders on the winglets. So the team that is runner-up in this year's competition is Team 13 from the National University of Science and Technology. The team name is NUST Airworks, and I believe you're based in Pakistan. So congratulations to you with an excellent solution. Thank you.
Thank you very much, Peter, and well done, Team NUST. Fantastic, well done indeed. So I have the honour now of letting you know who came 1st place. So clearly this is the team that whose combined scores from across the board enable them to get the highest marks there. So again, outstanding in all respects. And again, given the field we've heard today was so strong, this is absolutely absolutely amazing that the team got here. So before I tell you, so this is described as a to the people who do aircraft, you've got to work out if this is your aircraft or not as you design it, as I'll say it now. So described as a dual system hybrid UAV. It was chosen because of its ability to glide, hover, as well as do a vertical takeoff. The payload was partially recessed under the fuselage with a very interesting release system. The aircraft was flown in a fixed-wing configuration in X-plane simulation and performed very well against all of the test criteria and scoring very highly across the board. So we can really see that it was a very, very promising design for humanity and aid missions, which again was the aim of the brief. So the team that came first was the University of Petroleum and Energy Study, WRise, or WRise or RISE, that's how we could say it. So well done to that team, all sitting comfortably in their auditorium. Well done indeed, absolutely fantastic. So just to give you an idea of that fantastic design, which again I'm absolutely desperate to see. You come again next year and show us your design, please. And we're gonna a video now. I think we've got 2 videos of the design flying. We'll do our best on Teams to show that it can be a little bit jumpy. But we'll, as Christina said, we'll make them available afterwards for you to watch. So I think we've got it. The next slide is the video, I think. So as we saw there, that worked really quite well actually on Teams. So that was good. As you can see, how fantastic that was as a design. I said that the video, all those videos will be available to watch, and I ask that you do so because I think there's some fantastic work that went into those designs. So well done to you all for there. So I'll hand over now to Rob Porter, who is head of events and member engagement. Hi Rob.
Thanks, Paul. Yeah, it's great to see that video running so well. That's it does look great, doesn't it? So yeah, as Paul said, I'm Rob Porter. I'm the head of events and member engagement at the IMechE. Amongst many other things, my team and I look after the 5 educational challenges: the Unmanned Aerial Systems Challenge, but also the Railway Challenge, Design Challenge, Apprentice Automation Challenge, and Formula Student. So to reiterate what Paul said earlier, it's been quite a challenging year for the UAS Challenge, as it has for every other event, not just those organised by the IMechE, but for pretty much every other organisation in countries that have been affected by the pandemic. I've been working with engineers for quite some time now, and I'm constantly being surprised by their resourcefulness and adaptability. And this year's UAS Challenge has been a case in point. Throughout the year, we've been monitoring the situation with COVID very closely and writing and rewriting contingency plans. It's been a nail-biting time for us as event organisers, but I can honestly say that at no point have we ever felt worried about the UAS Challenge. The passion and expertise of the organising committee, coupled with the determination and the enthusiasm of the competitors, gave me great confidence that the event would take place in one form or another. In fact, as you all know, it's taking place in more than one form. The virtual competition you all participated in and the physical edition, which will take place at the BMFA Buckminster in the middle of next month. It's really great that although not all of you will be able to join us on the airfield, most of you have still been able to participate through the manufacturing support and test report and the X-plane simulation. I hope you've all enjoyed taking part and found it an enriching experience. Needless to say, a lot of hard work has gone into making this all happen, and I'd like to offer my thanks to my team, Jelena, Christina, Kirsty and Dan, plus everyone else who's been involved on the staff side. This hybrid format has been a first for us, and we've learned so much along the way, including some good ideas that we'll be taking forward into future years. Finally, I just wanted to reiterate how impressed we've all been by the standard of entries this year. You are the future generation of engineers, and I think the profession is in good hands. Thank you on behalf of the institution for throwing yourselves into the challenge, and I hope to be able to meet you all in person sometime soon.
Thank you very much, Rob. Yes, absolutely. So a really interesting time to do a trial out, a virtual challenge on the go. There we go. Absolutely excellent. So yeah, it worked really well for us. Thank you for your support. So now hand over to Jelena, who again is one of the stalwarts of this competition, to say a vote of thanks. This could take some time, so off you go, Jelena.
Hi, thank you, Paul. Hi, everyone. I'm Jelena Gatisha. I'm the operations manager of the education team, and my role is to handle 4 of our 5 student challenges and the institution's educational outreach work. I think I would start by saying that the 2021 UAS Challenge is a good illustration of the new environment of hybrid working, education and interaction of our time. The UAS Challenge virtual competition was introduced as a direct response to the COVID pandemic and the pressure, continued restrictions placed on students and in turn the competition. The IMechE saw a problem and did what engineers do best and engineered a solution. UAS teams rose to the challenge and once again illustrated true resilience and passion for learning. And as we have seen here today, the results have been truly impressive. I would like to start by thanking you, the students. I appreciate that many of you had hoped to be able to take part in the live fly-off event in July, rather than interacting remotely using simulation. Although this was not possible due to a number of reasons beyond our control, which we're all well aware of, you did not give up and embraced taking part in and making a true success of our first fully virtual UAS competition. You should be very proud of what you have achieved, and congratulations to not only the winners, but all of the participants. I would like to thank our sponsors, GKN Aerospace, Leonardo, Kinetic, Babcock, RS Components, Raytheon and Machine, as well as our partners, RPAS and Dropbox, for your continued support. As you know, and as you've seen today, our sponsors do not just provide us with financial support, but get actively involved with the competition and provide key industry insight, which helps us maintain industry relevance and enables us to offer better opportunities for you and equip you better as you go on to employment. I would like to thank our chair, Paul Lloyd, and the UAS Challenge Steering Committee for their hard work and dedication over a year that has been very challenging for most of us. I would like to give special thanks to Christina Linden and her team for putting the virtual competition together and practically building the UAS Challenge into the software. This was no small or easy task. Similarly, I would like to thank the judges and give a special mention to our head judge, Lambert, who does so very much for this competition. Last but not least, I would like to thank my colleagues Christina and Kirsty for their time and effort. Today is Christina Korsak's last day with the education team. It's a shame that she won't be with us at the fly-off event, as she has been so instrumental to the challenge for a number of years. Thank you, Christina, for everything that you've done for the UAS Challenge and for driving it forward and always going above and beyond what is required. Finally, I look forward to welcoming remaining teams to the BMF site in July and welcoming all of you back in 2022. Thank you very much.
Thank you, Lena. Thank you very much indeed. And I should say that the person that you clearly didn't thank is you. So thank you very much to you, because you didn't thank yourself, but you should have done. So thank you very much indeed for your support as well. And I just echo that support from the team, from my team that have made this work has been absolutely fantastic. For us, it's not quite over yet. We've we're able to have a live competition a little bit later next month for those that are able to come. And again, that Buckminster, so hopefully enjoy that. I'd also like to echo very much thanks to Christina Corsairs for your outstanding support, Christina, over a number of years now. In supporting the challenge. Good luck as you move onto maternity leave, and we will see you back, because you've been absolute stalwart, and I know you'll continue to support the IMechE and members across the board. So that brings us to the end of our virtual competition and the prizes. An outstanding event. I'd like to thank the over 100 people that have joined in from literally across the world. Whatever time of day it is for you, however you are finding your times at the moment, thank you very much for your taking part. Thank you much for engagement. It is no competition without you, so we need you back, and hopefully next year we'll see you back and we'll actually be able to get together. Let's be positive that'll be the case, and we'll be able to all join together in Buckminster in hopefully about a year's time to actually have a live event. And I really want to see some of those virtual designs flying and see if the real world was quite as good as the virtual world. But so thank you very much indeed, and until next time, see you next year. Thank you. Okay, I just say there's the overall scores. Thank you. I just say I believe I'm right, Christina. The certificates available on Mushroom site. Is that right?
Yes, that's right.
Yeah, great. Thank you very much indeed. So those are the scores, and we'll make all that information available to those who want afterwards.